Okay, in today's lesson, we are going to be putting everything we know about parent functions and transformations together to graph transformed functions. So we're going to start just by reviewing a little bit. So remember, this f of x equals this long equation here is a very general form of what a graph can look like or a function can look like when it's transformed. So let's just review how we get certain transformations. So the first transformation is a reflection over the x-axis. So if a is negative, it's going to reflect. Okay. And then I just look at a, and I know that a is going to make the graph have a vertical stretch or compression. And it's going to stretch if a is greater than 1, and then it's going to compress if a is less than 1. So if a is a fraction, then it's going to compress, and if a is like a whole number or anything bigger than 1, it's going to be a stretch. That h makes it shift left and right. So say I have like x plus 2 squared. That's going to move it left 2. If I have x minus 2 squared, that's going to move it right 2. Okay. And then my k at the very end is going to shift it up and down. So let's say I had like x squared plus 3. That's going to move it up 3. X squared minus 3 is going to be down 3. Okay. And you have this information in your previous day's notes. We just wanted to go over it again at the beginning here so that we remember all of these transformations. So just go through a few examples of this. So first we'll look at a linear function. So let's say I wanted to graph 1/3 x minus 3. The first thing I want to identify is that the parent function is f of x equals x because it's a straight line. And then this table gives me my parent graph. So that's how I got the dotted line on the right. The next thing I want to do is identify the transformations. So I always like to read the transformations from left to right. So if I think about my equation, the first number I see that's different than my parent function is at 1/3. And that tells me that I'm going to have a vertical compression by 1/3. Okay. And then this minus 3 tells me that I'm going to move down 3. Okay. So I'm going to come over here to my graph, and I'm just going to draw like each transformation one step at a time. So the first thing that I'm going to do is, since I'm vertically compressing by 1/3, it means that each of these points on my parent function is now going to be a third as tall as it was to start off with. So like right here, this value, I used to go up to 1, now I'm just going to go up to 1/3. In my parent function, I go up to 2, so I'm just going to go up to 2/3. Parent function, I go up to 3, so I'm just going to go up to 3/3 or 1. The 0 is not going to change, and then a similar thing is going to happen down here. I used to go down to negative 1/3, and now I'm just going to split that distance by 1/3. So what this is going to turn into is, I'm going to draw it dotted again, because this is just the graph when it's compressed. Okay, I just get this flatter line. Then I have to move that new graph down 3. So I'm just going to think about taking each of these points that I just drew and move them down 3. And it's not going to be perfect, but 1, 2, 3 should give you at least an idea. Let's move this one down 3, 1, 2, 3. And you don't have to move all the points, just enough to get you to the right spot, to get a good idea of what your graph's going to look like. So that solid blue line is going to be my final answer. F of x equals 1/3 x minus 3. So a couple cautions. First, just make sure that you do your transformations in order. You want to do them from left to right. And then when you start sketching multiple graphs of the equation, make sure you build on each other. Make sure you build on them. So like first I compressed the graph by 1/3. And then I shifted that graph down 3. So I want to make sure I shift my compressed graph down 3. Okay, let's jump to the next one. So the next one, I'm dealing with an absolute value function. I can tell that from the shape because it's a V. Okay. So this one actually has 3 transformations going on. The first thing I see is that I have a negative out front, which is going to reflect it over the x-axis. Then I have that 1/2, which is going to vertically compress by 1/2. And then this -3 on the inside is going to shift the graph to the right 3. Okay? So I have 3 different transformations. So I'm going to have 3 different steps when I start graphing on the right. I'm just going to do them all in a different color. So I'm going to start by doing the reflection in blue. So if I reflect this graph over the x-axis, then it's going to look just like an upside down V. Okay, so that's my reflected graph. I'm going to switch to green and I'm going to do the vertical compression. So if I vertically compress by 1/2, it means that all these points are going to be, we're going to half the distance that we used to go. Make sure I do this right. And this isn't going to be exact. I just want you to get it approximately right. Okay, so then that green graph represents once I've reflected it and done the vertical compression by 1/2. And then for my final step, I just need to shift that green graph right 3. So 1, 2, 3. And to be honest, I'm not concerned that you get these points perfectly correct. My concern is that you've got it mostly right. Okay, so I'm just going to shift some of these points. Let's see. 1, 2, 3. Okay. And your final graph's going to look kind of messy. I'm not going to lie. So what I like to do at the end is I have 3 different graphs here to kind of highlight that this red one's my final graph. If you have different colors, use different colors. If you don't, maybe put a star next to your final graph, or if you have a highlighter, just highlight your very final graph, just so that you know which one was your final product. Okay. All right, this one's a quadratic. So this one's one of the more important ones. So I see I have my quadratic parent function and the table created that helped me create that nice U-shaped graph. So let's just go ahead and look at the different transformations. So that 2 out front is going to be a vertical stretch by 2. That +5 is going to shift the graph, oh, not right. It's going to shift it to the left 5. And that +1 is going to shift it up 1. Then I'm going to go through and do all these transformations. So the first thing I'm going to do is I'm going to stretch my graph out. So I'm going to basically double all of the heights of these points. So my first point is 0, 0. That's going to stay the same because if I double 0, I'm just still going to get 0. If I take this next point, that height is 1, so I'm going to double the height to get 2. I'll get the same thing on the left side. If I think about this point is at 4. So when I double that, it's going to go up to 8. So that blue graph is going to be my stretched out graph. Okay, so I kind of just made it skinnier and stretched it out. Now I'll use my green to shift that graph left 5. In fact, I'm going to do the left 5 and the up 1 at the same time. So I'm going to move this point, this middle point, to the left 5. So 1, 2, 3, 4, 5, and up 1. So I'm just going to move them all at the same time. I'm going to move this point left 5 and up 1. This point left 5. This is going to be a little harder to see. Up 1. Okay. And I'm actually just going to use those 3 points to sketch my graph. If you think you can get a pretty accurate graph with just graphing those 3 points, that's totally fine. So then this green graph is my final graph for that one. Okay, so if you did it right, you should be able to look at the original parent graph, so in this case the black dotted graph, and your green graph, and they should have the same core shape, but where they're located on the graph will be different, and perhaps it'll be stretched out or flipped upside down or something. Okay, square root functions. So here I'm dealing with the square root function. So here's the parent graph, and then here's my parent table that allowed me to get the nice dotted black graph on the right. So let's go through all the transformations that are happening. This negative on the outside is going to reflect it over the x-axis. Okay, remember that you write down which axis you're reflecting over. That's important. That plus 6 on the inside is going to shift my graph left 6. And the minus 2 on the outside is going to shift it down 2. Let's go ahead and do this step by step again. The first thing I'm going to do is I'm just going to flip this graph upside down, because that's my reflection. So reflected over the x-axis, all the points that used to be above the x-axis now end up beneath the x-axis. Okay? And notice that my blue graph isn't perfect. It's not a perfect reflection of the graph, of the black graph, but it's pretty close, and that's what we're going for here. Then I'm going to move this graph left 6 and down 2. So I'm just going to think about this starting point right here, that end point, and I'm going to move it to the left 6, so it's going to end up clear over here, and then down 2. So that's where our new starting point is going to go. It's going to go left 6 and down 2. So now I'm actually just going to sketch this graph with just the end point. I know what the shape looks like. I'm just going to kind of try to mimic the shape over here. So this blue graph right here, the second blue graph that I drew, is my final graph. Okay. I think I've got 2 more examples for us to do. Yep. Cubic functions. So this cubic function is going to be fun. We've got a lot of transformations going on here. So let's first remember that this shape is the shape of a cubic graph. It's kind of like a funky S shape. So this 1/2 out front is going to be a vertical compression by 1/2. Okay. So let's actually just go ahead. Let's do these step by step as we write them. So if I vertically compress this graph by 1/2, it means that I'm going to basically cut all the heights of my points in half. So this starting point was 0, 0. If I cut that height in half, it's just still going to be 0. If I look at this point right here, I have a point -1, 1, -1, -1, sorry. If I cut that height of -1 in half, I'm just going to end up with -1/2. Okay, and then same with, if I look down at this next point, I have a point down here at 8, -8. I'm going to chop that in half to get a point right there at -4. So that's what that side of the graph will look like. And then the right side of the graph is going to look similar. And again, these aren't going to be perfect, and that's okay. I don't expect them to be. Okay. The key here is that you can see that if you take the black graph and you kind of put a hand on the top and the bottom of it and smashed it down, you can see that that black graph would eventually line up with the blue graph. So I've vertically compressed it. The next transformation I see in my equation is that I'm subtracting 1 on the inside, which means I'm moving the graph to the right 1. So I'm just going to take this blue graph and I'm going to shift all these points over right 1. And then I'm going to sketch that graph. Now this graph, the red graph, should basically run parallel to the blue graph. It's just going to be 1 unit over. And then my last transformation is at +3, which means I'm moving the graph up 3. So I'm just going to take all these points, the red points, and move them up 3. Oh, now it's starting to get a little bit messy because I have 3 graphs going on. So it sometimes is tricky when you're doing all these transformations to make sure that you don't mess any of them up. But just do your best to keep track of all the points. Okay, so that green graph should be my final graph on that one. Okay, I'm not going to run through all the last example for you guys. I want you guys to try it by yourself. I will tell you guys one thing. I want to talk about one thing. This negative on the inside of my square root right there, that's going to reflect it over the y-axis. Okay. This 2 I actually want you to cross out. We are not going to worry about having that 2 on the inside right there. That would be a horizontal compression or stretch, and we're not going to worry about that for now. So go ahead and work through number 6 and email me if you have questions.